Hello friends, welcome to Truth of Physics. Today in this video I will discuss the improved circuit of the constant current source using the transistor. Previously I have made a video on how can you use a transistor as a constant current source, but that circuit, so the link of the video I will give in the description box, but the circuit has some problems, the circuit have some drawbacks. Now to improve that we will discuss the improved circuit in this video. Okay, now what are the improvements? You can easily see that this is the same circuit, right? But there is only the improvement here in this part. There is an op-amp introduced. Now why the op-amp is introduced, let us understand that. Now first we will discuss that what was the drawback in that circuit. So the drawback was whenever the transistor is in compliance limit, that is an active region, then what was happening, then even in the compliance limit, within the compliance limit, whenever the resistance was changing its value, this was a variable resistance. So when we change the resistance, then what should happen? Okay, this is a constant current source, means when we change the resistance, then also this IC should remain constant, but that was not actually happening. Why that was not actually happening? Because when you rise up this resistance, when you change the value of this resistance, suppose it is increasing resistance value, so then the current should decrease, because current is what? I equals to V equals to IR, that means I equals to V by R. So here R is increasing, that means the current here should decrease, but that will not be the case. The current will not decrease. The decrease in the current will be compensated by decreasing this voltage by the transistor. So the transistor will decrease this VC voltage down. So the VC voltage will be decreasing and that will compensate. So as this is decreasing, so the IC will increase, so that IC will remain constant within the compliance limit. Now but there is another trick here, and that is VC is changing here. That means VC minus VE, that is called VCE, will change, VCE will change, and as this VC changing, that means as a consequence, using the early effect, due to the early effect, VBE will also change, that means VB, this quantity will also change. Now VB is constant, VB is 5 volt, DC 5 volt, that means only this quantity will change, VE, this will change, and as the voltage at this point will change, that means the current in this circuit, in this line, you can see that the current will be changing. That means this current is what? This current is nothing but our IE, and we know that IE is just equals to IC. That means as IE is changing, that means IC will also change. So the conclusion is, within the compliance limit, even within the compliance limit, if we change the resistance, then also the IC is changing with a very small amount, okay, little amount. So this was not working as a accurate constant current source. Now this circuit can overcome this problem. How? Here it is a op-amp, right? Now this is the negative feedback of this op-amp. Now is this negative feedback working properly in this circuit? Let us understand that first. Now to understand that the feedback in a op-amp circuit is working or not, we have to do a thing. Suppose the voltage at this point is X. Now for any reason this is increasing. Suppose this have increased, this is increased, then as this is increasing, it has increased, that means the voltage here, negative terminal, will increase. That means the input voltage difference will be negative now. As a result, the voltage here will be decreasing, and as the voltage here, as the input voltage difference is now negative, that means op-amp output voltage will start to decrease, and as a consequence the voltage here will also decrease, and as a consequence the increased amount of X will be now decreased. So the X as a whole will remain constant. So the op-amp will work in such a way to make this voltage constant, and as negative feedback is operating, the op-amp will work in such a way that the two input voltages of this op-amp will remain same. This is the operation of op-amp. Whenever there is the negative feedback is operating in an op-amp, the op-amp two input will be at same voltage. The op-amp will work in such a way to maintain the input voltage at same voltage. Okay, so 5 volt will be reflected here and that will be reflected here, so X is nothing but our 5 volt, right? So X is 5 voltage. Now, so if this voltage is fixed, now you can easily understand that whenever in the compliance limit you raise this resistance, you increase this resistance, then the Vc will decrease to make this IC constant, but then Vc will decrease, that means Vc will change, that means VB minus VE, and that is VE will change, but that will not change because of the operation of the op-amp. Op-amp will work in such a way that op-amp will maintain this voltage, right, VE. So the VE is now not changing due to the op-amp, due to the operation of the op-amp. So as VE is not changing, you can understand that IE, the current here will be what? VE, that is 5 volt divided by 220. So this will be a constant current IE, and as this is constant IE, so IE is equals to our IC, so IC will also be constant here. So here in the compliance limit you can see that it is matching with the theoretical result. Theoretically it should work as a constant current source accurately. And here also in the compliance limit, if you change the resistance, then also the IC is not changing, and you can justify this result using a multimeter to check the current in this line. Okay, just check the current in this line using a multimeter and changing the resistance value within the compliance limit, then you can see that IC will not change. So this is the improvement, and this is the accurate constant current source circuit, okay, improved. So I hope that you have understood that how the circuits can be improved using this type of op-amps, okay, and all the necessary things, or I think that you have understood all the things. So if you have any doubt, then you can comment below and share this video with your friends. So take care of yourself. Thanks for watching.